The process of resolution is opposite in sense to composition of forces. However, the fundamental intention is to ease the composition process. We have seen that a set of forces can be combined to establish a resultant force. Similarly, a given force can be split into different combinations of multiple forces such that the combined effect will be same as the single force. Consider a specific scenario where the given force F is split into two components in which one of them is oriented along the horizontal direction and the other along the vertical direction. Let us name the horizontal component as Fx and vertical component as Fy. The angle between them is 90 degrees. Assume the given force F is inclined at an angle theta with the horizontal. For the right angle triangle ABC, AB by AC is cos theta. From the geometry, AB is Fx and AC is F. And the equation becomes Fx is equal to F cos theta. Similarly, BC divided by AC is sin theta. Substituting BC as Fy, the equation becomes Fy is equal to F sin theta. These components are acting at 90 degrees and are called rectangular components. This procedure can be adopted for splitting given forces in any orientation into components along a set of mutually perpendicular axes. This forms the basis of generalized method of composition. We have already seen that for collinear forces, composition of forces is simply finding out the algebraic sum. The process of resolution transforms the given forces in any orientation into groups of collinear forces and make the composition process much easier. We will go through a sample problem to have a better understanding of generalized method of composition of forces. Consider a rigid body acted upon by a set of coplanar concurrent forces. Let us construct x and y axes along the horizontal and vertical directions, considering the common point as the origin. Forces F1, F2 and F3 are acting at angle θ1, θ2 and θ3 with the horizontal. Magnitude and direction of the resultant force need to be established using generalized method of composition. The first step is to split each force into horizontal and vertical components. As seen earlier, F1 can be split into horizontal component of F1 cos θ1 and vertical component of F1 sin θ1. Let us use a short representation of F1x for the horizontal component and F1y for the vertical component. In a similar fashion, F2 is split into F2 cos θ2 and F2 sin θ2, and F3 is split into F3 cos θ3 and F3 sin θ3. This process transforms the inclined forces having different orientations into a group of collinear forces in horizontal and vertical directions. We know that for collinear forces, the algebraic sum of component forces yield the resultant. Components along positive direction of the axis would be considered positive and those along the negative direction would be considered negative. This should be accounted while finding out the magnitude of the resultant. Thus, algebraic sum of horizontal components yield a resultant force in the horizontal direction and algebraic sum of vertical components yield the resultant force in the vertical direction. Using parallelogram law of forces, a net resultant of these forces can be established. As the angle between them is 90 degrees, the magnitude of the same will be square root of sum of squares of both the components. Let us assume that the resultant force R is making an angle theta with the horizontal axis. From the geometry, tan theta is Ry divided by Rx, which is same as sigma Fy divided by sigma Fx. And the orientation of the resultant with horizontal axis would be Rtan or tan inverse of sigma Fy divided by sigma Fx. Now we have estimated the magnitude and direction of the resultant force. For a concurrent force system, the line of action of the resultant also will be passing through the common point. And so the resultant of the concurrent system is completely defined using generalized method of composition. Before concluding, let us cross-check the result with graphical method as explained in the previous video. It can be seen that polygon law of composition yield the same resultant. Composition of forces for non-concurrent force system is covered in separate videos. Suggest watching the same for clarity.